So far we have the pug moving left and right. We don't have gravity yet, and we don't fall through land. We don't have collision detection. So I think it's time to make the pug jump and at the same time add some basic gravity. So to do that, we're first going to need some new properties to keep track of what's going on with the character. So one of the things that's important is the state of the tile underneath the character. So we'll call this something like underfoot state for now. I can't really think of a better name. So keep track of tile under character. And this will just be an unsigned int as usual. And we'll do underfoot state. And then we will also need to, as we're doing this, not forget in the setup to make the defaults. So let's do this as we're going so we don't forget. And then in this case, we want it to be a flag. So similar to like the joystick when you're doing left and right and things, we're going to just define some states that could happen underfoot. So we'll do, say, foot, and then on land, and we'll make it, when you're doing a flag, you want unsigned integers, and you want to basically go 1, 2, 4, 8, and then after that, you 0 that side, and you do 1, 2, 4, and 8. And by doing this, you can OR them together and get different values. So if you took a look at the programmer, and in hexadecimal you put 1, you can see the binary as 1. 2, then it's the second bit. 4 is the third bit. 8 is the fourth bit. And then if you do 1, 0, you can see it's in the fifth bit, and then the sixth bit, seventh bit, and finally 8th bit. So by doing the hexadecimals in a stagger order, you're effectively allowing then all logic to work as a kind of flag to select multiple versions. So all these things could be true at once. You could have the foot is on land, the foot is in air, which obviously would not normally be together, but it's still something you might want to consider. You could have on lava, which is a perfect example of, say, where you could be on land, so you can walk, but you're also on lava, so you need to do damage. And let's do, say, on water as well. And then with those, we can set up the underfoot state when we get to that. Next, we'll want to keep track of if we have jumped. So we'll call this has jumped. And this will be important because the logic for when we're doing the jumping is kind of semi-unrealistic. We don't apply a force at the start and then gravity takes over. We can actually let go of the jump button midway through a jump and have the character fall. This is classic in Mario games, so if you just tap the jump briefly, you'll barely jump, and if you hold it, you'll jump further. So that kind of logic doesn't work in real life if you were doing real physics. Once you've left the ground, you have no ability to then control how long it will take to come back down based on releasing a button midway. So we have to do it by tracking progress as we go. You'll see how this works when it comes together. So flag indicating if we have jumped. And then once we've jumped, we'll want to keep track of the jump height. And this will allow us to track, since we left the ground, how high we've gone up in order to limit the maximum jump height. So keep track of the jumped height. Let's just make sure to default those as well. And then let's just go and see what we want to do here. Let's just remove this calculative in air. This will be calculated differently now. We're going to store that based on the tile we're under and different ways of doing it. We'll want to update the predicted Y now. Now we're going to use that. And make sure we do predicted Y here. So all we need to do is something similar to the X, where we set velocity in some kind of logic like this. And so the first thing I'll probably do is, we know we need some kind of collision detection or interaction with the level. So we'll call this sort of level interaction. And this is really a to-do because this is a bigger task than what we want to do at the moment. So this is where you detect when the player moves around, what's around him in terms of the level, what's under his feet, what's to the left, what's to the right. And then we can move, and then we can apply physics, and then we could do collision detection after or before. It all depends on where it wants to fall. But to start with, before we apply movement, we need to understand what's around us in the level. So in order to jump, we need to know, is there ground underneath us? So that's a thing on its own that would be, process level interaction. For now, because we're not interested in that topic yet, we want to just do the jumping, we do need to set the player's underfoot state. So we'll do some really simple logic at the minute, and we'll just set it based on the character's Y position. So if the Y position is greater than or equal to 120, which is where we move him to. So basically, if he falls below that or is on that, he's on ground. So super simple logic for now. If it is, we'll set it to foot on land. Otherwise, we'll set it to foot in air for now. Just keep it nice and simple. That will give us the ability to now use this logic in our code. And now we need to get some velocity so that we can do something with velocity. Oh, good job I saw that. Velocity Y. So let's look in the joypad area for now. Up and down we're not really using. We'll probably use them to look in future, to be able to like look up and down and things or enter places. And then jumping will be the A button being pressed. Jumping isn't that simple. Like you press A and then you do something. It's a lot more complicated than that. So jumping as a hobble won't be an else if. It's whole kind of area on its own. And the first thing we need to check before just being able to jump with A, so that's valid logic to start a jump. Can we jump? Well, that's defined based on the character's underfoot state having the foot on land. So if you and them a single and, you effectively find out whether the foot state includes the on land flag. And as well as that, we must be pressing A. So this will only happen now if we are pressing A while on land. And then all we need to do is set the characters has jumped to 1. Mark character has jumped. So that's step 1. And I'll probably change that to have we jumped. So what comes after that? Well, once we have jumped, we need to apply some velocity. So if we have jumped, and that will be defined by the has jumped flag, and still have button pressed. So as well as has jumped, you also need to have buttons and JA. So this is effectively right after this. It will happen in the same loop. If you're on floor, you press A, it gets set to has jumped. It will come straight to here because it's not an else if. It has jumped when we still are pressing. So now this will apply the velocity. So we want to apply upward velocity. And remember, negative goes up, so we'll do -1. And we must keep track of the jumped height. And this will help us in the moment to limit the maximum we can jump in the air. So we'll do character.jumped height ++. And it's not really a height as such, so jumped steps or jumped frames, I guess. So I'll probably rename that to jumped frames because it's more accurate. The velocity will get added to the movement there, not velocity, because the movement will get added to velocity and velocity will increase. It's not necessarily a height, it's based on gravity and other things. So it's just more of a frames than a specific height. So we'll just rename that to jump frames because it makes more sense. And I think that will be it for now. We can do all the limits and stuff after, but we have some basic velocity coming in. So now let's apply that movement to the velocity. So if character dot movement force isn't equal to 0, so we are actually moving, or we need to move. So while jumping, I guess, or while trying to jump, we have some movement wanting to be applied. We can just do, for now, let's just do the velocity Y and add the character movement force. And then we will want to do some gravity. So else if and you might as well check this, the character is on air. So if the character is underfoot of air, we want to apply gravity. So otherwise, if in the air, apply gravity. So let's just do character.velocity y - for now, super simple. And let's see where we're up to at the minute. Let's get a gauge for what's going on and if it's generally working. So pressing A does nothing at the moment. Spot the issue. We're setting movement force directly here, not move Y, and then we're overriding it with move Y after. That's what that'll be. Let's try that again. It was a difficult one to see. And there you go. You can see now when we jump, we just infinitely keep going forever. And that is because we have no logic at the minute as when we let go what to do. So basically, once we jump, we are setting the movement force to a value and never removing that movement force. And then every loop, we are increasing it by that movement force, which never goes away. So the next thing to do, you can do it in between or wherever, I guess it doesn't really matter. We want to say if we no longer have the A button pressed, so we've let go, or when to end the jump, or be more descriptive, I guess, makes more sense. End jumping if not pressing A or gone above frames, which we'll have to do after. And then once you let go of that, the character.hasJumped becomes 0 because you're no longer jumping. And the character's movement force, more importantly, gets set to 0. That should now allow us to jump and let go. And it should actually then have gravity being applied. We can see there, probably due to the fact that we have no limit yet on the maximum velocity for a start and no ground, we'll still just see the pug flying. So let's now just put some basic velocity limits in. So if the character's velocity is something, so it's actually moving, and the character's velocity is going more than -3, then the character's velocity will equal -3, so there's your limit. And then let's just do that in the reverse, so it's greater than 3. And that's just really basic velocity limits. Let's have a look at what that does to our character, see if we can gauge. There you go, so you can now gauge that when you press and release, it's still not coming down. So that should be hitting that when we let go, and it's actually going in the wrong direction because I've done minus. Gravity should go in the positive. So now we should get, there we go. So now we can jump, and when we land on the, in fact, yeah, so once we pass ground, we can kind of jump again. But you can just hold it infinitely. So at the minute, there's no limit on how high you can jump, and there's no detection of ground level. So let's fix those two things. Let's do a basic, and then this is where once you've done predicted, you'd want to do something with the predicted. So this would be, I guess, detect collisions as the start of it. And you would want to pass in the address of predicted X, the address of predicted Y. So we can set them directly, and obviously the character itself, which is already an address. So update predictions based on collision. Let's just chuck that above here. So this will be void detect collisions, character pointer to the character, and then the predicted movement was uints of 8. So this will be predicted X, predicted Y. And because these are being set directly, so instead of being altered and copies, we'll pass them as pointers. And then all we need to do now is detect if we are past a certain floor and then update these values. So this is really basic for now until we detect the level. So that will be if the predicted Y as a pointer, so we get the actual value, is greater than or equal to the 120, the temporary floor at the minute. So then we just need to update the predicted Y, which is where we want to move, basically. And don't forget the pointer equals the 120. Snap to ground, and let's remove velocity. Because we have hit the ground, we don't want the velocity to carry on, it wants to be an instant stop. We'll just remove that in the detect collisions. So if we hit ground, and this is just a temporary, really cheap and easy way to detect when we hit the ground. We now have the call at the right place, which I feel is after we've predicted where we're going, calculate if we can go there, and then move the character. So let's see if that now works and allows us to hit ground. And there you go, you can see. We can now run around. Ground is just ground, so it doesn't detect this fall at the minute. And we can just hold A to jump permanently. And you can obviously move around in the air while you're jumping. So the next thing now is to limit the maximum jump. And we have that set up partially in here. We have this tracking of jump frames. So now we want to limit here, so where we jump, that we are also not over, so the jump frames isn't greater than max jump frames. Let's say for now, let's just do a define. And we can have this passed in if we want. And you could even have that set on the character. It's literally up to you. You could pass that into, as a character, as a value. For now, I'm just going to define it. And we'll do, say, 15. And this will be not an and, it will be an or. So basically when we're stopping, so either you let go of A or your jump frames goes above the max, we'll then reset the jump. And let's see what that does. We should now not be able to jump any higher. And there's the limit. But you can see now once we've landed, we can never jump again. And that will be because we've never reset the jump frames. So once we've started jumping and we've gone above, we are forever in this permanent jump frame is greater than max frames. So when do we reset the jump frames? Well, you don't want to reset them mid-air or as you're falling, because that means you could jump again in mid-air, potentially. We want to detect when we are on land again, basically. So if we are on land again after jumping is what we want to detect. And to do that, we will do if the character underfoot state is now on land. So that's check 1. And we have actually jumped. Otherwise, we'll be constantly resetting while we're stood on the floor doing nothing. So you want to make sure the jump frames is greater than 0. Otherwise, this would just run forever all the time. You are on land at the start, and if you didn't do this check, you're just permanently going to run into this. So let's make sure you've at least left the ground. And once you leave the ground, so the minute you've started to leave the ground, reset the jump height. So this will reset. And reset has jumped. So this is your kind of reset. So you'll jump in the air, you'll land, and then this will go to true, and this will always be above the max frames because you've landed. So then before even holding A, basically as soon as you land on the ground, the next frame it resets. So you can't jump for one frame between landing on the ground and starting a new jump, which is completely unnoticeable. So this should allow us to now jump over and over. And you can see there's now a bug there because we're going in the air and then instantly falling. And that's probably just the order we're doing this in. So let's just move this up above this check. So we actually have some jump frames being set. And let's see if that helps. I think it's just the order of the thing. There we go. So if we were to reset the jump frames to 0, it would constantly negate this one where it's adding the jump frames. So order of priority, basically, or if else. It doesn't really matter which way around you do it. I'll just leave them as ifs independently. So you can see we can now jump. We can also let go midway, but it feels a bit harsh, and the letting go instantly resets velocity. So let's just work on the gravity because it's a bit crude. We just instantly apply gravity as soon as we let go. So I'm going to say let's do a kind of taper at the top, like fake math, similar to we did with the X and Y. To do that, we're going to just do frame counting again, like we've done for the animation. So we have movement, animation frame count. Let's add one more, jump frame count. And this is to allow us to do kind of math on sub-pixel levels, nice and easy. And to do that, we just want to count, in this case, so jump frame count from 0 to 60. And it doesn't really matter, because this is just, when you let go, you want to taper gravity. And we're going to do that in under 60 seconds. So we'll just make a basic counter that just keeps looping. So it equals the jump counter plus 1 and just remainder 60. So it'll be 0 to 59 all the time, counting up forever. And then all we need to do before we start calculating the jump action here, let's just reset jump counter every time we start a jump. So at the start of a jump, it's reset, or rather at the start of a fall. And to do that, we just simply check if the last movement on Y isn't 0, so something was happening. But now the character is no longer wanting to move, so effectively you've let go of the A or you've reached the maximum. Then we can just set the jump frame counter to 0. That now gives us a jump frame counter that counts up from 0 as soon as you start falling, and we can use that per frame to taper in some gravity here. So now using that frames, we'll basically just say at the start of the jump, so if jump frame count is less than 5, so the first 5 frames after releasing, we'll just directly set the velocity. So we won't even do minus minus, we'll just directly set velocity. So we'll continue upwards a slight bit. And then if the jump frame counter is over 5 but less than 10, we will then set it to -1, and you get the idea here. So we'll do a couple of stages, probably 3 more stages, 4 more stages, and we'll do, once we are at the top, so just for 4 frames you want to hold at the top, not too long, and then 6 more frames before we start to go positive, and then anything after 6 frames go full speed to the ground. So let's see if that gives us a nice kind of taper when we jump. So you can see now you have a nice smooth jump, and you can let go at any part of the jump. And that's very similar to a Mario style jump. The only thing I've noticed, if I tap really quickly, I don't jump every single time. So that is something to do with either the velocity is not strong enough, so we just haven't moved up enough. So I think one of the problems is this on a single call, because we're doing this logic of if jump frames is above 0 before we reset the jump frames, it's not always going to call this reset of jump frames, because there's a logic where you'll be on land but your frames was never above 0. So instead of doing this blocker call here, which was to prevent the first call missing, we'll move either this into here to always reset regardless, but I think we'll also move this as an else, because the only job is to prevent the character from jumping until we land again. Well, if we're on the floor and we've pressed the A button, we don't care about resetting this yet. We want to reset this once we're back on land and not holding the A button. So let's see if that logic allows us to have better jump. There we go. So that's now fixed the quick tap jump. So let's just revert the gravity back to what it was, which I believe was that, I think. Let's see if that does what we need. There we go. So now we have a jump every single time without fail. So that's fixed that bug. We have this other bug that I've noticed. You can just tap quickly and do a double jump. Now, kind of a feature, and you can still get to max height just above there, but you can get a bit higher. So it seems if you let go and retap right before the maximum, it's allowing us to do a double jump. So let's try and fix that logic. Let's just make all this logic simpler, and let's, instead of counting up always and then resetting when we're falling, let's just constantly reset the jump frame every jump, and let's move this jump frame counting then into the section where we are applying gravity. So there's absolutely no doubt then that this logic should run and only happen when we are jumping. There we go, that's now definitely working on there. But we can still do this weird double jump, and it does appear, I'm sure that's a 1 frame reset of jumping somehow. And I think I've just spotted the problem. It's really minor, but you can see here what I've accidentally done is knotted the button and then anded the A. So this logic is wrong here. I've put that bracket there by mistake to invert the logic. I'm pretty confident that's going to be the problem. Also, this won't be needed because this is already defaulted to 0 at the top. That can actually just go. But hopefully that was the bug in the jump. Finally, there we go. That was a tricky one to spot. And now you've got jumping every time you tap without fail, even the quickest tap, and you can jump to any height. So that's now the jumping finally sorted. So it was mostly simple, just with bugs that probably took longer to finish than the overall logic. I'm quite happy with that jump. It seems kind of natural. The speed's right. I think maybe the animation just needs playing with, make him look a bit more running. That's about the only thing, but I think the overall pace of the game there, when the level's moving, maybe move him a bit quicker. But we'll see. So for now we have the jumping and basic floor detection, and I guess next would be to actually detect the level properly, so we can jump up onto platforms, fall through these holes, and then we'll get the scrolling working. So that's it for this one, guys. I'll catch you in the next.